The most dangerous place during a societal collapse is often the place that looks the safest. History repeatedly shows that human beings are drawn toward familiar shelters, recognizable infrastructure, and locations that seem protected by design. Yet when supply systems fail, communication networks fragment, and millions of people suddenly compete for the same limited resources, these seemingly logical refuges can transform into deadly containment zones. Emergency management research, disaster case studies, and basic environmental science reveal a disturbing pattern. Many locations people instinctively move toward during crises are structurally incapable of sustaining large populations without the invisible systems that normally support them. Electricity, logistics, sanitation, fuel distribution, and law enforcement are not conveniences. They are life support systems. Remove them, and the very places designed for comfort or security become engineered traps. What appears safe on the surface often hides a cascade of systemic failures that unfold slowly, invisibly, and then all at once. One of the most common assumptions during disasters is that large cities provide the greatest chance of survival. At first glance, this belief appears logical. Cities contain hospitals, warehouses, transportation hubs, government buildings, and dense networks of infrastructure. They are designed to concentrate resources and services. But this concentration creates a structural vulnerability that disaster planners refer to as dependency density. A modern city operates through continuous high-volume logistical flow. Food deliveries arrive daily. Water systems rely on electrically powered pumping stations. Waste removal operates on strict schedules. Fuel pipelines and trucking routes supply transportation networks that move millions of people and goods every day. When those systems fail simultaneously, the urban environment loses its ability to function within hours. The misunderstanding comes from confusing resource presence with resource availability. A city may contain thousands of tons of food at any given moment, but most of it is already allocated to stores, restaurants, and distribution centers operating under just-in-time supply chains. Modern logistics research shows that most urban grocery systems maintain roughly 3 days of stock under normal consumption patterns. Remove resupply and increase demand through panic buying, and the window shrinks to less than 48 hours. Once food scarcity begins, population density amplifies the crisis. Millions of people searching for calories in the same gridlocked streets generate immediate competition, and competition rapidly destabilizes social order. Emergency management studies repeatedly document that the first major pressure point in urban disasters is not structural collapse, but supply collapse. The hidden science behind this phenomenon is metabolic demand. Every human requires roughly 2,000 calories per day to maintain baseline function. Multiply that by a metropolitan population of several million, and the city requires billions of calories entering the system daily just to maintain equilibrium. Urban agriculture within city limits contributes only a fraction of that requirement, often less than 1%. Cities are not designed to feed themselves. They are designed to distribute incoming resources. The moment distribution halts, the entire metabolic load of the population becomes unsustainable. Infrastructure engineers refer to this as a throughput system. Remove throughput, and the system stagnates. Evidence from real disasters supports this pattern with uncomfortable clarity. During large-scale hurricanes, winter blackouts, and infrastructure disruptions, emergency planners observe that cities exhaust retail food supplies within hours. Fuel shortages follow immediately because transportation systems depend on continuous refueling cycles. Water systems begin to degrade as electric pumping stations fail or lose pressure. Hospitals shift to backup generators designed for temporary outages, not long-term grid failure. Waste management stops entirely. Garbage accumulation accelerates bacterial growth, attracting rodents and spreading disease vectors. These cascading failures are not dramatic cinematic events. They are slow mechanical breakdowns of complex systems that were never designed to operate without power and logistics. The survival implications are severe. Population density multiplies every shortage, every sanitation failure, and every logistical bottleneck. Roads become immobilized as residents attempt mass evacuation at the same time. Transportation research shows that highway networks are extremely efficient under controlled flow but collapse under chaotic demand. When millions attempt to leave simultaneously, gridlock forms faster than vehicles can move. Fuel runs out while people remain trapped inside their cars. Emergency responders cannot navigate through immobilized traffic. What began as an attempt to escape the city turns into a stationary population exposed to dehydration, exposure, and rising conflict over resources. The escalation becomes even more dangerous when water systems begin to fail. Modern urban water infrastructure relies heavily on electrically powered pumps to maintain pressure in distribution lines. Gravity-fed systems exist in some regions but often require upstream pumping to refill reservoirs. When pressure drops, contamination risk increases dramatically. Backflow from damaged pipes can introduce bacteria into the system. Without chemical treatment plants operating continuously, municipal water can become biologically unsafe within days. Dehydration then emerges as a silent killer because humans cannot survive more than a few days without clean water, especially in hot climates where perspiration accelerates fluid loss. As sanitation collapses, disease risk rises exponentially. Wastewater treatment plants rely on constant electrical input to maintain aeration and filtration processes. When those systems fail, untreated sewage can enter waterways or back up into drainage systems. High-density living conditions accelerate the spread of gastrointestinal diseases, respiratory infections, and vector-borne illnesses carried by insects and rodents. Epidemiologists emphasize that disease outbreaks historically follow infrastructure breakdown far more often than they follow the initial disaster event itself. The true danger is rarely the trigger event. It is the environmental instability that follows. Yet despite these well-documented risks, millions of people continue to believe that remaining inside major cities provides safety because of the visible presence of buildings, hospitals, and government facilities. This belief persists because the collapse of invisible systems is difficult to imagine. People see skyscrapers and assume permanence. They see stocked stores and assume continuity. They see police stations and assume order. But these institutions function only as long as the complex web of electricity, transportation, supply chains, and personnel remains intact. Remove even one of those layers, and the entire structure begins to weaken. Emergency planners often describe cities as metabolic engines. They require constant input and constant circulation. When the engine stops, the environment quickly becomes hostile to the very population it once supported. Heat islands amplify temperature extremes when air conditioning systems fail. High-rise buildings become vertical obstacles that trap residents dozens of floors above ground without functioning elevators or reliable water pressure. Fire suppression systems depend on maintained water pressure, and when that pressure drops, even small fires can spread uncontrollably through dense structures. The urban environment, which once concentrated safety services, now concentrates risk. This is why disaster response agencies consistently emphasize early evacuation when infrastructure failure appears likely. The critical window occurs before transportation networks become saturated. Once that window closes, movement slows to a crawl and escape routes become parking lots. Unfortunately, human behavior during emergencies often delays decision-making until visible signs of collapse appear. By that point, millions of others are making the same realization at the same time. The resulting surge overwhelms every exit corridor simultaneously. And this leads directly to the first so-called safe location that repeatedly becomes a death trap after systemic collapse: the urban high-rise apartment building. At first glance it appears secure, elevated, protected from flooding, and structurally strong. But hidden within its design are engineering dependencies that transform it into one of the most dangerous environments once power, water pressure, and supply chains disappear. Because the moment elevators stop, water pumps fail, and stairwells become the only access points, the towering structures that once symbolized safety begin to behave less like shelters and more like vertical isolation chambers. At first glance, a high-rise apartment building appears to offer every advantage during a collapse. It is built from reinforced concrete or steel, elevated above street-level chaos, and surrounded by thick walls that seem capable of keeping danger outside. Residents imagine that height provides visibility, defensibility, and insulation from the disorder unfolding below. But the engineering logic of high-rise construction reveals a very different reality. These structures are not designed to function as independent survival habitats. They are designed to operate as vertical extensions of city infrastructure. When that infrastructure fails, the building itself begins to fail in ways that are subtle at first, then rapidly life-threatening. The first hidden vulnerability is vertical dependency on mechanical systems. In buildings taller than roughly 6 or 7 stories, gravity alone cannot deliver water to the upper floors. Pumps must push water upward through riser pipes to maintain pressure. These pumps run on electricity. When the electrical grid shuts down, water pressure begins to drop almost immediately, especially at higher elevations. Within hours, faucets slow to a trickle or stop completely. Toilets stop refilling. Fire suppression sprinklers lose pressure. The residents on the 20th or 30th floor suddenly face a basic biological reality. Every gallon of water must now be carried upstairs manually. The misunderstanding comes from assuming stored water inside the building will last. In reality, high-rise plumbing systems contain very little reserve capacity. Water towers exist on some buildings, but many rely entirely on continuous pumping from municipal lines. Once pumps stop and municipal pressure drops, the building's internal plumbing becomes an empty network of pipes. People living dozens of floors above ground now face a brutal energy equation. Carrying even 10 liters of water up 20 flights of stairs requires significant physical exertion, and dehydration accelerates quickly in stressful conditions. What looked like a secure tower becomes a vertical endurance challenge few people are physically prepared to manage. Hidden science intensifies the problem through thermodynamics. High-rise structures trap heat. Without powered ventilation or air conditioning, upper floors experience a phenomenon known as thermal stratification, where warm air rises and accumulates near the top of the building. During hot seasons, indoor temperatures can climb dramatically above outside temperatures. Residents on higher floors may experience extreme heat stress, especially in densely packed apartments where cooking, body heat, and poor ventilation compound the effect. In cold climates, the opposite occurs. Without heating systems, wind exposure at high elevation strips warmth from the structure faster than ground-level buildings, producing dangerous indoor cold conditions. Evidence from major blackouts reveals how quickly these problems escalate. During extended power outages in dense cities, emergency responders frequently report residents trapped in upper floors without water, struggling to descend dark stairwells to reach limited aid supplies. Elevators remain disabled, lighting fails in interior corridors, and emergency generators, if present, are typically reserved only for limited systems such as fire alarms or minimal lighting. They are not designed to sustain the entire building for days or weeks. As conditions deteriorate, stairwells become crowded lifelines used simultaneously for evacuation, supply movement, and emergency response, creating bottlenecks that slow everything down. Survival implications become clear once sanitation collapses. Without running water, toilets cannot function. Waste begins accumulating inside individual apartments. In densely occupied buildings, this leads to rapid bacterial growth and foul air conditions that make living spaces increasingly hazardous. Residents may attempt to dispose of waste outside windows or in hallways, which accelerates contamination and disease spread within the structure. What began as a secure residence slowly transforms into an unsanitary containment zone where hundreds of people are confined within the same failing environment. And this pressure leads to the next overlooked trap, another location people instinctively flee toward when systems collapse, believing it contains the supplies needed to survive. The modern supermarket.